I am Ms. Vrabel, and we're going to start with Module 2, Lesson 1. There are going to be many times I ask you to pause your video, work problems, and also some of the example numbers may be wrong. Just find the problem in your module because Eureka changes the numbers every year and they could be incorrect. All right, here we go. Alright, for this lesson, you're going to need a pencil, a paper, lots of loose leaf, whatever kind of paper you have, and Module 2, which you should have gotten at school. It looks like this. So the book. You can also print this online if you need to, but it'd be easier if you have it. Alright, I'm going to ask you to copy notes and vocabulary for every lesson. That's going to help you answer questions for homework. So these are the notes you need to copy. So my recommendation is go ahead and hit pause and copy them. I'm going to just go through them. Alright, this is a number line. You probably are very familiar with a number line. As numbers go to the left, they get smaller. As numbers go to the right, they get larger. 0 isn't positive or negative. It has no value whatsoever. So if you had like a -4, it's smaller than a -2 because it's further to the left. All right, some vocabulary you need for this lesson. Number 1, absolute value, which is, you've probably seen the notation word, but it looks like this. Like 2 little bars, kind of like a field of gold. All right, absolute value is the distance, so the number of spaces a number is from 0. Opposite, it's the same number like 4 and -4, but it has a different sign. So if it's positive, it becomes a negative. If it's negative, it becomes positive. Additive inverse is just a fancy way to say opposite. So one thing to note, opposite quantities or numbers combine to make 0. Like that -4 and 4, if you put them together, you have 0. Alright, so this is your first exercise in the module. So if you'll turn to the page where you see this Venn diagram and hit pause again and just fill in what you know about negative numbers, positive numbers, and what they have the same goes in the middle. Alright, so there's really not much to say on this except negative numbers are on the left side of 0. Positive numbers are on the right side of 0. Words that you usually see associated with negative is like lose, they lose yards, or you could lose money. Temperature might decrease or it goes down. So negative numbers have a negative in front of them. There's a bunch more. Positive numbers, you do not have to put the positive in front of it. You can just write the number. What they have in common, they're both on the number line. Kind of an easy one. All right, let's move on. All right, go ahead and find example 2. All right, counting up. So in this module or this lesson 2, it's very important that you know this vocabulary. So counting up means you're going right, counting down means you're going left. So if you go right of 0, you're going to have positive numbers. If you go to the left of 0, you're going to have negative numbers. Alright, so some questions they want us to answer. A says, where do you begin when locating a number on the number line? So you always want to start at 0. Alright, B says, what do you call the distance between the number and 0? So how many spaces are between that? We already said that's absolute value. C says, what is the relationship between 7 and -7? So they have the same absolute value, so they're the same distance from 0, but the important thing is that they're opposites. Alright, and move on. So this lesson really talks about this card game they want you to play. However, since we're not at school and you don't have the cards, we're not going to try to play a card game. We're going to skip everything that talks about that. But for the time being, what I want you to do when they have problems like this, don't worry about it saying that they're on cards. We're just going to figure out what the value is when you combine those. Alright, so I'm going to show you how to do that on the number line. So you start at 0, and the first number is 5. So I'm going to make a little loop that goes from 0 to 5. And put an arrow right there. Alright, now each number that's added to it, you do another one above it. So the next one is -5. So -5 means you're going to go left from where you ended up 5 places. So if I go left 5, here's 1, 2, 3, 4, 5. Guess what? I ended up back at 0. Alright, so now I'm going to go left 4 places, back from where I ended up. So 1, 2, 3, 4. End up at -4. And from there I'm going to go 8. So it's positive, so I'm going to write 8. So from here it's 1, 2, 3, 4, 5, 6, 7, 8. Where you end up is your answer. So I ended up on the number 4. So 4 is my answer. Alright, what's the final position? That's where you end up. So I ended up on 4. What card or combination of cards would you need to get back to 0? Well, I could just move left 4, and I'd be back at 0. You could do other things like move left 2 and then move left 2 again. Alright, go to exercise 2, the additive inverse. Remember, additive inverse is another word for opposite. So what I want you to do is go ahead and pause your video and work these problems right now, and then I'll work them with you. Alright, starting at 0 and counting up 5 units and then back down 5 units, like in the previous example, brings us back to 0. This is because 5 and -5 are opposites. Work independently, which you already did. To answer the question, exercise 2, they want you to do this using the number line. How far is 7 from 0 and which direction? So in order to answer that, I'm going to go to 7 and see how far it is from 0. Here's 7, here's 0. So it's 1. Don't count the spot that you start with. Count the next one. 1, 2, 3, 4, 5, 6, 7 places from 0. And in what direction? How far is 7 from 0? So here's 0. To go to 7, I have to go right. So it's 7 places to the right. All right, what is the opposite of 7? So the opposite, remember, is just that number with a different sign. So the opposite of 7 would be -7. How far is -7 from 0 and what direction? So in order to show you that, I'm going to erase this. All right, how far is -7 from 0? Here's -7, here's 0. So how far is -7 from 0? 1, 2, 3, 4, 5, 6. It's 7 from 0. And in what direction? How far is -7 from 0? So if I went to 0, -7 would be 7 to the left. All right, thinking back to our previous work, explain how you would use the counting on method to represent the following while playing the integer game. The first, all right, we're going to skip that one because it talks about the card game that we're not doing. All right, so I'm going to go ahead and answer E. What does this tell us about the sum of 7 as opposite -7? It's 0. All right, look at the curved arrows you drew for 7 and -7. What relationship exists? So what they're looking for is it's the same length. So you have the same length. And we're going to quit making little loops. We're just going to make it one straight line. Do you think this will hold true for the sum of any numbers opposite? Yes. And the reason why is because they have the same absolute value. Alright, so here's the properties that we're talking about for the additive inverse. Stuff that you already know. You add a number to its opposite and you're going to get 0. Alright, so now looking at example 4. How would the value of this card represent a temperature? So -10 would be like -10 degrees. It'd be really cold if it was -10. How would the temperature need to change in order to get back to 0? You'd have to add 10. All right, the second thing says write a story problem that using money that represents the expression 200 plus -200. So you could say something like you have $200 and then you pay a bill that's 200, so you're losing that 200, so now you're at 0. All right, how do you model addition using a number line? That's where you made the little loops. If it's positive, you go to the right. If it's negative, you go to the left. So how could you find the sum of -5 plus 6? You'd start at -5, and then you go 6 to the right. Peter says he found the sum by thinking of it as -5 plus 5 plus 1. So the question is this an appropriate strategy? It is, because 5 plus 1 is 6. So they just found a different way to say 6. You'd get the same answer. Why did he do that? Because 5 and -5 gave you 0. So he easily was able to get the answer. All right, go to your exit ticket. Go ahead and pause your video and try to work the exit ticket, and then we'll work it together. Alright, this is talking about that card game that you didn't play, but we can still answer the question. It says your hand starts with the 7th card. Find 3 different pairs that would complete your hand and result in the value of 0. So that's kind of the goal in that whole game, is to end up with a value of 0. So you have lots of ways to do it. The most obvious way would be if the first one is 7, you could make the second one -7. You're already at 0. So then the third card has to be 0. There actually is a 0 in this thing. So now what I have to do is I have to make these 2 cards add up to -7. I could do -3, -4, or I could do like -5 and -2. There's no really limit to what you're gonna do here. There's lots of ways to do it. All right, 2 says write an equation to model the sum of the situation below. A hydrogen atom has a 0 charge because it has one negatively charged electron and one positively charged proton. So one negative would be -1 plus one positive would be just 1. If you add them up, you have the charge of 0, which is what we're trying to get. All right, let's move on. Three says write an equation for each diagram below. How are these equations alike and how are they different? What is it? Oops, sorry, I didn't mean to do that. What is it about the diagrams that lead to these similarities and differences? All right, so remember the first number is the one that's at the very bottom. So if I go to 0, it looks to me like I'm moving all the way to the number 4. So the first number is 4. Now to that 4, go back up to the top right here. I'm going left 1, 2, 3, 4. So I'm adding -4. All right, on the second one, on the bottom, I started with 0 going to -4. And on the second number, I'm adding positive 1, 2, 3, 4. So how are they the same? They're both going to add up to 0. How are they different? The order changed in those. That's the only way they're different. All right, thanks for watching. I'm Miss Vrabel at Lee Junior High, teach 7th grade. If you have any questions, I'm happy to help you. See you later. Thanks.